have his own set of broadcast video, but one or two moderators could also broadcast as well alongside in a window alongside it. And one of the things that happened, yes, Jack, you remember, one of the things that happened was that I was enjoying my Kentucky Fried Chicken while my camera was on and enjoying it with immense relish. Those were the days. And then the last time I broadcast Chicken Man, that's right. I broadcast an image of me enjoying some nachos and salsa. Now, in case some of you are wondering, well, my goodness, does he only eat junk food? Rest assured I do not. And as proof of that, here, Sparkle Cam. Here. Not switching. Oh, god damn it. All right. What I wanted to do was to turn the camera on towards me, and you could have a look of, you could watch me enjoy a nice little bowl of lemon lime Greek yogurt. So yes, I do eat healthy once in a while. Doesn't want to pick up. All right. Well, that's probably because. All right. Here we go. My goal tonight is to measure the focal length of my telescope. Now you say, how do I do that? It's pretty hard to do when if you're trying. Yeah, Jeff, the yogurt would kill you. Dairy allergy? No allergies at all. I just enjoy the taste. Also have a drink next to me. Well, it's not a drink. It's a pop, or it's a caffeine-free Diet Pepsi. And someone once told me, what's the point? I mean, there's no sugar and no caffeine. There's only fizzy black water. Well, I enjoy the taste. So anyway, back to the lesson. So if we want to determine the focal length of the telescope, we have to determine essentially what is the field of view that we see on our chip. Now I'm going to be switching from the live broadcast to the browser on the remote computer outside, so I can show you a couple of pages. One in particular is this one, which is the basis of my determination. Now, determining the focal length of your computer essentially requires basic trigonometry. There's a nice site that explains it all here. Aperture, no, not that one, sorry. Light Vortex Astronomy, how to very accurately determine your telescope's effective focal length. What I'll do here, math, no, yeah, I know, don't worry, it's only going to take a couple of minutes. I will post a link here. Got the link there. Okay. Now it says you might be reading this thinking that is absolutely no point since your manufacturer tells you. However, because I'm going to do some astrometry, that is the measurement of positions of asteroids in the sky, so I can help refine the orbits at the Minor Planet Center, they require that I know my focal length to, well, they say within 10%, but I can do pretty much better than that. So if you go through that page that I just linked to, it shows you a nice explanation of what happens to a light ray with a CCD camera, and then there's this little bit about the angle subtended from a point-like object way at the left towards infinity onto part of the chip. Okay. Of course, that angle, the little angle, the opposite side divided by the adjacent side is the tangent, which can be low angle values is just the angle itself in radians. Anyway, blah, 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 blah. There's a lot of explanations here, so I will not bore you with the details. If you go towards the bottom, you will see that there is a formula right here. Focal length in millimeters of your telescope is, okay, conversion factor from degrees to radians, which is 206.2648, times the pixel size in micrometers divided by arc seconds per pixel. Yeah, trig math. So one of the two variables in that equation, the pixel size in micrometers or microns, we know from the specifications of the chip that Rock sells. The 432M has a pixel size of 9 microns. So what we need to determine then is arc seconds per pixel. And how are we going to do that? Well, you will be joining me in trying to find a star field, and I will be using another site that will do a plate solve of what I am looking at, and it also gives some useful information as to the pixel size, etc. I will show you one I did with the focal reducer. This is what we're going to be looking at. Remember the image of the Sunflower Galaxy I did a couple of, like a week and a half ago? It essentially plate solved this, and of course it took from the image, the FITS image, or whatever format image it takes. Actually it takes BMP, whatever format of the image. The size, the number of pixels, which in this case is 1600 by 1100. It plate solved the image, and it gave me a pixel size of 1.12 arc seconds per pixel, which is exactly what we are looking for when we're trying to determine the focal length of the telescope. Now, I applied this to my telescope with the focal reducer, the 0.5 with the spacer, and my telescope went from 2080 millimeters to 1060, which is pretty close to f5. So I got to determine exactly the focal length of the telescope with my setup, which if I wanted to do astrometry with the focal reducer, I would need to know. Now I'm just determining the exact focal length of the telescope without focal reducer, just by curiosity to see what the actual focal length is compared to the advertised focal length. Here. I'm going to go on the Meade website to make sure that it's, I'm not telling you, but it says 2000 even. Okay, it's, well. So my telescope was brought down to their advertised value of 2000 to 1060, which was determined with this image. Now what I'm going to do, yes, they're an average. You're exactly right, Jack. They're an average for a given series of scopes. So I like to determine exactly what my focal length is. So what I'm going to do is I'm going to find a bright star and crank up the gain so I see a star field around it, take a picture, push it through the nova.astrometry.net website again, and let the site determine the value that I need for the pixel scale, which is in this case with the focal reducer 1.12 arc seconds per pixel. Now since I'm at f10 instead of f5, I'm kind of half expecting this to be about half, which is going to be about 0.55, 0.57. So I'm just going to take. So let's see. All right. First of all, Malin Can, I need to find a star. I'm going to go to Arcturus. Now I just did a quick alignment on the moon, so by going to Arcturus, I'm not sure how close I'm going to get with the actual telescope, so I might have to slip out and just manually find it with the finder so I can center that field of view so I can sync on that again. So, all right, named, enter, and I gotta go down through all the stars that have a beginning of al, Cade, al, nath, al this, al that. Essentially, there's a whole bunch of astronomy knowledge from the Greeks was saved by the Arab culture, and of course they renamed the stars in their own language. And al, the prefix al, essentially means the. Okay, the star, the bright star, whatever. So that's why a lot of stars that came, for which we still have names for now today, begin with al, which means the something. All right, Arcturus, enter. Let's see how close I get. I'm going to increase exposure time because I'm at F10, so... Yeah, as I thought, I am nowhere near any star. So I am going to step outside, and I'll be right back. It'll give you a bit of a break in the lesson. And Arcturus's great means bear. There you go. So some names were retrieved from the Ptolemy's. What's the book that he had? He wrote a catalog of he named about 400 stars or something like that. So anyway, there is a faint star there. I'm going to go outside. I'll be right back because I want to make sure that I get Arcturus in the field of view. Ooh, way too much gain. Let me bring that down here a bit. Almagest, that is correct. Thank you, Dan. See? There were smarter people than me online. All right, I'll be right back. See you in a couple of minutes. Are you recounting how I'm got the name Chicken Man? I don't blame you. It was fun. Okay, let me reconnect to the computer outside. Oh, if there is a picture that exists of that moment, I do want to have a copy of it. Oh, it's right there? Oh, let me see. Oh, that was at Ekvar. Yeah, that was at Ekvar. Yeah, you're right. That was good chicken, too. Oh, good. That was about 9 years ago. 10 years ago. Okay. All right, for those of you wondering where I'm at in the sky right now, I initially went to Arcturus. However, it's still a bit too close to the moon, so it was very bright. I couldn't get any dark background. So instead I went to Alcor, which is almost straight up. So I'm going to get minimum glow. And yeah, and I've also adjusted the focus somewhat. So what I'm going to do is try to get some... Oh, look at that. I'm not touching it. All right, now the artifact at the bottom is when I did a dummy dummy flat field. I was too close to a light source, so yeah. But that doesn't matter too much. Okay. So as you can see, I do see some stars. I am going to move a bit. There's Mizar. Actually, Alcor and Mizar was used as a sight test for the French army in the 19th century. Essentially, the recruits were asked in the night, "Can you distinguish those two stars?" If they said yes, they were hired. Yeah, the dark curve at the center bottom is when I did my dummy flat field. I was a bit too close to a source of light, so yeah. Don't worry about that. If I take out the flat field, it'll disappear. But you'll see that the dust bunnies. Although it doesn't look too bad, so I'll leave it there. Yeah, there's a little speck of dust on the chip itself. I seem to have one speck of dust in my camera that moves about, so try to shake it off. Okay, now let me check against my star chart. Zoom in. Okay, so the stars that I'm seeing in the field of view right now, you see these four little stars. There's a fourth one here. Well, actually, there's a faint one right there. Let me see if I can't determine. It's magnitude 13, so we're 13.3. So I'm not doing too badly tonight. Yeah, I'm limited. Okay, it's magnitude 13. So I'm at about magnitude 13 right now. It doesn't appear like I have that many stars, but just for the heck of it, I am going to take this snap and go over to astrometry.net and show you what it looks like. I think I have enough stars. So, but to increase my chances, I'm going to do a live stack 20 images, just so I can bring out the background a bit more. Clean up the noise and get the stars see moving already. All right, now that I have, apart from the dust bunnies, now that I have a clean image, I'm going to take a snap of this, save it. Let me go check the website. I want to remember the format that they take. And they take JPEG, GIF, PNGs, or FIT. So I'm going to save the image into PNG. Save image. All right, I've saved the image. So I'm going to go to nova.astrometry.net/upload. I'm going to copy the link and include it in the discussion. All right, sorry guys, I think I disconnected myself from the group. So, all right, let me come back here. Let me put these. I do snafus. All right, back to the clear image. Can you still hear me? Okay, good. All right. So I'm going to continue my little lesson here. All right. Here is the address of the site. From there, let me go to the home page here. From there, it explains to you a bit what it does, and it shows you some recently submitted images. I go to upload. And it's going to be literally as easy as just uploading the image, click upload, and let it do its work. So I'm going to choose the file that I've saved earlier. 0505, Alcor Mizar.png, upload. Now it goes to a page where it says, all right, thank you for your submission. Please bear with us while we process it. It says it usually takes within 10 minutes. It takes no more than a minute or two. So I don't even need to specify where I'm pointing in the sky. It's going to solve it by itself. All right, 15-second lag with the sound and the image. Okay. Got maximum bandwidth on, so. Oh, not the sound, the image. Ah, okay. Right, let me see. Okay, let's go back here to the image. So you see now the image that I've uploaded there's a small thumbnail showing, and it's waiting for the process to start. It says go to results page, but there's no point in going there yet. We let it work a bit more, and then we're going to get in maybe a minute, maybe less. In the next room, I'll be right back. There you go. I come back right on time for the results. Now, it throws out a whole bunch of numbers at you, and it probably would have it, but if you click to the Go Results page here, yeah, I know astrometry.net can sometimes take some time, but so far it's been pretty good. Anyway, if I go to the results page, we'll see in about 15 seconds, I'm guessing. It identified the stars. Okay, and we get our magic number here. The size of the image it says I have. No, 1600 by 1100. All right. Well, that's what it says. That's what it says. Right here. So we get our critical number here of 0.738 arc seconds per pixel. Let's keep that number in mind. I'm going to go back to the page with the formula. Thanks. Focal length is, we need to apply this formula right here. I can't zoom in a bit so you see better. Let me punch in those numbers and determine what the focal length of the telescope is. It should be around 2000. If it's not around 2000, then I know I've done a mistake somewhere. It was 6.2648. Okay, pixel size in micrometers, we all know from the specs that it's 9. So we multiply that by 9. And we divide that by 0.738. It gives me a focal length of 2,515 millimeters, which I think is wrong. So let me go check to see what the results were on astrometry.net. Yeah. 8 inches f10 is 80 inches. 80 inches convert. Maybe around 2000. I'm getting 2500. So for some reason I am not getting the expected. You're getting 2032, Jack? Did I make a mistake in my calculation? I highlighted the wrong number. Math, yes, I know. Math is wonderful that way. I mean, sometimes mistakes creep up when you least expect it. Here. Tracking really well because between the live view and the image I took, there's virtually no difference. Oh, 8 inches in millimeters at 2032. Yeah, so it should be around 2000. So I'm wondering why I don't have a focal. Okay, I'm trying to remember. I don't have a Barlow. Lenses at all between the telescope and the. All right, call this my failed lesson. because it did identify the stars correctly. Go on the star chart and put on the Tycho catalog, I should see. Oh, you're recording my lesson. Oh, great. For posterity, watch me make a mistake. I don't mind. I'd rather do a mistake and learn from it. All right. What is wrong with my methodology? An image. Okay, let me deactivate. Binning, no. Method average, that's 1500 by 1100. Correct. It's 9 microns. That's odd. Okay. Don't know what to say, folks. He sold me an F12 or 14 telescope. No, I'm not capturing from the screen on NSN. This is the image is captured straight from the software on the remote computer. As you can see from the scale on top, it goes up to, let me move this a bit, to 1600 by 1100. So I'm not, no, I'm not scaling. That was my initial worries, that what am I doing wrong? 100% scaling and take a snap of that, but I'm pretty sure that I'm going to get the same size image. That. 2. Save it in another form. No, it shouldn't form. Save. Let me go check the second file. 1600 by 1100. I don't see why. Oh, let me do live stack first before taking an image. Yeah, that's probably why. Darker. Live stack, I'm going to center this a bit better. Hi, Don. Save a snap. It should save at what you have set up on top. Yeah, and I've got it on top here, 1600 by 1100. So it doesn't matter what, whether I'm at 50% or 100% for viewing the image. That's just an image viewer zoom. So, okay. Now that I've recentered the field of view to have enough stars, I'm going to start, before doing a stack, I see another faint stars appearing here. Now I'm going to do a live stack of 20. Hi, Don. You've come to join me make a mistake while it's being recorded because I'm trying to determine the focal length of my telescope. Yeah, I know. It's all in good fun. All right, 12 have been stacked. As soon as it hits 20, I'm going to snap this. Save the image as this, but version 3 now. And let's go back to the astrometry site. Let's go to upload again. Let's let it do its work. Now I'm doing this again because I want to look at the numbers before I go to the next page after that. I want to see if it really says 1100 by 1600 or if it's scaled up a bit for some odd reason. Good, the thumbnail is there. Step is the numbers. Yeah, that's what I'm wondering, Jeff. I want to see if the site is resizing the image. It shouldn't. And actually, if I don't see the numbers that I want to see here, well, I'm going to go to the results page. There's a couple of fits files that are downloadable, and I'm going to look at the headers to see if it really kept these 1600 by 1100 scale. Processing. Size. 285, quad stride, zero match. Seed. Yeah, that's what I might try to do next. Let me see the... yeah, no calibration data available. Okay, so let me go back to the software here. I'm going to disable live stack because I'm going to center this. Live view on screen. Save in JPEG. I will follow your advice. Doing science together. Ooh. All right. This. Not save this, but let's stack this, and I want to see what I get. See, the sky is really getting, well, the sun has really set now, so the background is much darker. I'm going to save it in JPEG and save it in Fix, and let's see if there's a difference. Astrometry.net takes fits. Yes, it does take fits image. Okay, good. Here, all right. I've got a stack of 20. Let's snap. Save that snap. Now we're save it first of all in JPEG. Also going to save as. All right, back to the upload section of the website. Let's try the JPEG first. Fits in JPEG. Let's wait. Yeah, I use PNGs just from my web design days way back when. If I can't find stars, maybe what I have to do is bring up the gain a bit more just so it picks up the fainter stars more easily. A bit of yogurt. Giving me odd numbers. All right, success. Let's go to the results page. At 0.738 again. We look at the Start Fits Viewer from NASA. Second. Of course, I'll try to do something and everything explodes on me. I gotta. And I can't access network drives with this. Oh dear. All right. The network drive. Image size here, 1600 by 1100. That's odd. So what was the number I arrived at? 2,500 focal length? Yeah, that is strange. Let me redo my math here. 'What was it? What was the value? 0.738? Do math anymore. 2,515. Okay, so they sold me an F12-13 telescope, which I find odd. The optical train is just a straight 8-inch LX90. I've got a behind that I have a diagonal, and then I have a moonlight focuser, then the camera. If you want, I can go and take a picture. I'll be right back and I'll post it on the group here. Meanwhile, I'm just going to put the Malan-Cam image back here. I'll go take a picture of my optical train and I'll be right back. Should be around 2000. Be right back. Yes, it should be 2032 for an 8-inch f10. All right, first of all, I gotta get the image. Rose. Go. All right, it's on my Google Photos here. So I will show you what my optical train is like. This is probably the best image. That's what it looks like. Okay. As you can see, this is the back of my 8H f10. I've got an Antares 2-inch diagonal, which plugs into a moonlight focuser here for fine focus, because the big knob here doesn't really do fine focus properly. And here's the object of desire of mine for a long while, the Malan-Cam 432M. So, what does everybody think is what does anyone think is happening here? Yeah, moonlights are really nice. I've jury-rigged this the knob here to have a gear for the ETX90 electric focuser, and the motor is kind of a snap-on. I'll explain that another time, but essentially when it works, because now I've stripped a gear, I can use the focus on the AutoStar to control the focus. You're right, Michael. This system seems to be acting like an f2.3, a 12.3. This is the same optical train that I've used in my in the past, yes. No, this is not the scope I had at EGVAR. The scope I had at EGVAR was my 10-inch f4 Schmidt Newtonian. I'm waiting to install my 10-inch f4 until I get a more solid mount. I may be getting an LX850 soon, so. Until that time, I'm using my 8-inch LX90 on a wedge. So, this brings up an interesting question. Does the addition of the diagonal extend the the optical train to the point where it actually increases the focal length of the telescope. Why? Because essentially the mirrors are, well, I mean, their curvature is fixed. One interesting experiment would be that I remove the diagonal and put the focuser directly in the back here, and the Malin cam there. So essentially removing the diagonal. But you're right, Michael. It should not change the focal length of the telescope. At a loss. You're right, Jack. It should not. So have I been sold a f12 telescope? Yeah, I'm interested in trying it too. If you don't mind bearing with me, I am going to go and do what I just said. Yeah, I have one of those rare meads. Collector item. Ooh. But Michael, you're right. I will go, if you give me about 5 minutes, I'm going to remove the diagonal here, put the focuser directly in the optical back, and I'll have to refocus. So give me about 5 minutes. I'll leave it here, and I shall return. Latest messages that I missed. It does increase the magnifying effect by increasing the focal... Let's do the experiment and find out what it looks like. This will be a new lesson. See, we do learn stuff after all, so... All right, let me connect to the remote computer. Okay. Here's Alcorn Mizar again. I'm gonna clean up the image. Skies are wonderful outside. If it wasn't for the moon, we could go really, really, really deep. No wind, no scintillation of the stars whatsoever. It's just wonderful. A stack of 20 to clean up the image. Oops, looks like there's a bit of wind. Nope, so let's redo the stack. Oh, yeah, I gotta flip the image so I get north up again. Okay, disable that. There, that corresponds to my star chart. Okay, now let's do this. No, I'm using the 432. Actually, yeah, I kicked myself out and back in again, so I'm just going to rewrite the... There we go. I just added the details of my setup in my little text. And while I did that, I got a I'm going to keep it anyway. All right, let's snap this. I'm going to save this. Now, since the file format was not the issue, I'm going to go back to PNG since this is what I'm used to. I had version 4 earlier, so this is going to be version 5. Let's go to the website and let's do the math. Upload an image, choose a 5, upload. Sit back and enjoy. And if you saw colors in there, you might want to check your monitor. Okay, it says 10 minutes. It'll take a lot less time than that, as we all know. Meanwhile, I enjoy another spoonful of delicious lemon lime Greek yogurt. Okay, now processing is going to begin. There we go, results. It's still processing. Still processing. Yes, all right, results page. Oh, son of a gun, the pixel scale has changed. At 0.894. So let's calculate what my new focal length is, see if it's closer to 2000 as it should be. Six. Okay, 0.894. My new focal length is 2076 millimeters. So, what have we learned today, boys and girls? If you add to the length of the focal optical path in your Schmidt-Cassegrain and change the focus, you change the effective focal length of your telescope. Isn't that amazing? No, we're looking for something around 2000. So now I'm effectively at 2076, yeah, at about a f11, plus or minus. You're right. Who would have thunk? So congrats to the one who found the quote, to Michael in New Hamburg. Thank you for finding that. So effectively, when you change the focal length, yeah, the pixel length, if the focal length of the telescope was 2032 as advertised, the arc seconds per pixel, the pixel scale should be closer to 1. So get rid of moving mirrors. Yep. Wasn't that useful? So yeah, that's quite interesting. So that means that if I want to do astrometry with if there's no moving mirrors, then there's no change, which is why I like the Schmidt-Newtonian, because it's essentially a Newtonian. The mirrors don't change. So the consequences for this, for me, if I want to do astrometry, is that each time I set up my telescope, I essentially have to do a plate solve with this, determine the exact focal length, and use that in the in Astrometrica, which is the software that is used to analyze the astrometry to send to the Minor Planet Center. Yeah, Jeff, you're right. Your F11 will be much higher. Wait, aren't you the one who's bought a whole bunch of who bought a Bader diagonal that's got a few things connected to it? Yeah. So, surprise, Jeff! You just increased the effective focal length of your telescope. Or use the same optical train every time. Yeah, no, I agree. Yeah, you're right, Don. I mean, if the optical train doesn't change and I never touch the big knob focuser on my Schmidt-Cassegrain, but only use the Moonlight microfocuser to do the focus, then I should be fine. You're correct. Isn't that interesting? Oh, if I remove the Moonlight, it would probably be even closer to 2000. The only thing is I don't have the 2-inch optical back for my 8-inch LX90. I only have the one that came with it, which is a 1.25 inch, which the Mellencam 432M doesn't fit in. I need an adapter. Now, all right. Now I want to try something. I want to go see M51, which is close by. I want to see what it looks like at F11. So I'm going to sync on Alcor here. Go to M51. I want to see what it looks like. M51, enter. Right, let's hope that the alignment is good enough. I haven't muffed it too much when I changed the whole thing. Hi, David. Okay, I'm nowhere near the whirlpool. I may be near the whirlpool galaxy, but at F10 it's pretty hard to find. So let's go back to Alcor and Mizar. Just resync on that again. Let's see. I go to Alcade, yeah, okay. But let me go to Alcor first. I want to make sure that it's kept the alignment. Okay, I've synced on Alcor. I agree. Let's go to Alcade. May have to go outside to center it in the Finder if it doesn't appear here on the field of view. Oh, we may be in luck. There's Alcade. Yeah, David, we're actually closer to F11. We did an interesting experiment where, actually I can show you. This is a picture of my optical train behind my 8-inch LX90. There's a diagonal here, and then my Moonlight microfocuser, and then my camera. And we've discovered that when focused with this optical train, the focal length is about 2500 millimeters, which brings it at about f12. I went outside afterwards and removed the diagonal to have the microfocuser directly into the back of the telescope and remeasured the focal length, and it's closer to about 20, what was the value? 2076. So with Schmidt-Cassegrain telescopes, which have moving mirrors, each time you change the focus, you change the effective focal length of your telescope. Live and learn. All right, let me just sync on out here. It is very interesting indeed, which means that you're better off, if you do astrometry, you either have to remeasure the exact focal length of your telescope before doing your measurements, or you use a telescope with no moving mirrors. So either you find a way to move, did I? You either find a way to lock your Schmidt-Cassegrain main mirror, or you use a telescope with no moving mirrors. All right. Where it takes us. Yeah, it has to be within 5%. So the difference with the diagonal is 450 millimeters in focal length, which is way more than 5%. I mean, it's closer to, my goodness, 15-20%. So Oh, look at that, M51. All right, let's center that, and we'll start to do our magic to bring up the... Well, of course, Jack is recording this. So initially I thought, oh, I must have done a mistake, so we've recorded my mistake wrong. But no, we made an interesting reality check. All right, there's M51. Let me boost the exposure time on this at 5 seconds. I want to see what I get. Overexposed. I'm going to touch the gain down a bit. Of course, at F10, it's going to be more sensitive to any small gust of wind, and I've just seen it move a bit. Mode instead at about 10 seconds. Yes, it is a learning experience, Jack. We've all learned together. Yay! Oh, that's going to be nice. I think it's going to be nice, but let's do a... Let's let this telescope stabilize a bit. It seems to be moving a bit still. Yeah, Michael, I'd be curious as well. I think at F10 or closer to F11, any small jiggle on the telescope is going to show up in the averaging, and yeah, it's starting to smear about a bit. So let me go back to shorter exposures, back to 5 seconds. Yeah, I know I'm doing fine given the conditions. It's too bad the moon is out because the rest of the sky conditions are absolutely perfect. What I could do is go put the focal reducer on and get more brightness. But let's try stacking 20 of these for the fun of it. Yeah, move it closer, yeah. saying something. Bring down the white level a bit too. No, it's there, I agree. Well, if I had the 2-inch optical back that screws in directly into the back of my 8-inch LX90, it would just slide directly in. Extra F doesn't normally bother me either. Yeah, you're right, Jack. Now I'm curious to put the focal reducer in and measure the effective focal length with the focal reducer without the diagonal. Oh, we're not doing too badly here. Playing with the settings here because I haven't done... Yeah, the detail is building up nicely. Of course, I have nice donuts. I have to clean my... Optics is like math. Yeah, well, optics is math, essentially. Yeah, we're seeing the dark dust line inside this spiral arm right here. We're seeing the bridge up to the second, the satellite galaxy. It's looking good, actually. It's looking really good. Got a bit of amp glow, I think, but yeah, that's fine. Hi, Bob. Oh, I think the scope, there was a gust of wind. Not bad for F10, F11, you're right, I like it. Okay, I'm going to go outside, I'm going to put the focal reducer in, and we'll try M51 first, and then we're going to go to a star field and measure the effective focal length. But before I do that, I'm going to stop the stack here. This is what it's stacking right now, if you can imagine. Let's stack, hoping that the scope has stabilized a bit. I'm stacking 20 images right now. Now up to 5. And again, there's a bit of a gust of wind that just hit the scope. Yes, I am. Yes, I want to. I did MPC work before, and I want to do it again. So I just want to get a better mount for my 10-inch f4 Schmidt Newtonian from Meade, and then I'll be able to resume my activities there. And again, the telescope is wobbling. So I want to get a better mount. Yeah, I like that one, Michael. Neat. Graduate students as windshields. Tricore. Okay, let's see if it's gonna stack with if the scope won't move. Yeah, I will resume. I haven't done so in a little while, but I will be submitting stuff to the MPC again. All right, the telescope is moving a bit. I'm going to go outside. I'm going to put the focal reducer in and we'll re-image M51, and then after that we'll redetermine the focal length of the telescope. I will be right back. No, I didn't forget to stop the camera. There we go. I forgot to connect to there. All right. Yeah, sure, but if you want to talk about submitting data to the MPC, you sure send me an email. Okay, let's see what happens when I add 20 of these. You need my email at. There you go. Here's my email address. Okay, so let's see if we can't bring out some details on this. Yep, big difference. Well, we'll know exactly how many percent smaller in a few, in about 5-10 minutes. Well, actually, I could probably use this star field as a on astrometry.net and find out what it looks like. I don't have a flat field applied. Flat field was done in a very lazy manner earlier this evening, so it won't work really well. I'm pretty sure this will work. Oh yes, of course, exposure time is way down because of the reduced focal ratio. Yes, it will be much more sensitive with reduced focal ratio. Let me try to improve on this image a bit, and I'm going to do something drastic. Stop, live stack. Use the same settings that I used the other. Let's adjust the histogram before stacking. I want to see if I can't maximize. That might blow up the core a bit, but the arms should come out nicely. So let's stack 30. There we go. It'll take 90 seconds. Let's hope the scope doesn't move too much. You can see the noise is smoothing out nicely. And the scope moved again. Darn it. This is actually good enough to go and do an astrometry run while this continues to stack. So I'm just going to snap this. Reducer. While it's accumulating here, I'm just going to start a let it do its work while we're looking at this. There's 40 images stacked. This is with a nearly full moon. Oh, you're welcome, Jeff. Yes, it's always nice to know more about your equipment, and as we've discovered tonight, I've discovered more than I intended to discover. So, but that's a good thing. So we've all learned from this. We thought it was a mistake. We figured out it wasn't, and we discovered that it was because when you have moving mirrors in your optical setup, it changes the focal ratio. There you go. All right, so that's at f10. Let me zoom in to there's a I'm not too happy. There seems to be a touch of coma, which is normal because if the focal ratio is reduced and I'm using a focal reducer, coma will start to appear, which means that if I don't want coma, I have to use my optical train as it was and increase the focal ratio a bit. Okay, let's see if astrometry.net did its magic. It did. Let's determine the magical focal length. Here's the number we need is the 1.35 arc seconds per pixel. So let me go get the formula again because my memory is awful. I'm turning 50 next week. Stupid memory. 206. And we have to aha! Focal length is 1,375. So, this is interesting. Because if you increase the focal 1,375, and with my setup with my when I did have the diagonal and the focal reducer in, the focal length was about 1,060. If I want more effective focal reduction, I have to put in the diagonal. 6.76, yep. And when it was 1060, it was closer to f5.1, 5.2. And so there's M51. What time is it? May have to clock out soon anyway. Although all right, you want to go for a globular cluster? Yeah, it's very nice. It's not bad at all considering. I think the focus is okay. What was the globular cluster that we were looking was it M3? Oh, look at that. We are getting good alignments, good go-tos. Stacking. Hope the scope doesn't move too much. Just going to clean up the image a bit. Yes, the spacer, you're right. There's a spacer that goes between the camera and the focal reducer lens. Quite a bit. We see a bit of pixelation there. Touch. There. Much better. I think it's close to 10 millimeters. I'd have to go and measure. Ah, there you go. Jack just provided the answer. So there is M3 in all its glory. Yeah, it looks very nice. It's in black and white, of course. I mean, but one of the reasons why I like black and white is that I don't need to fiddle with colors and white balance and whatnot. So yes, there are advantages to monosensors. is extremely sensitive. And this is a stack of 30. So, all right, this is M3. Was it M3? Is M5 not too far? If M5 is not too far, I'm game to go and have a look at it. Oh no, it is a bit of a, oh, it's close to the moon. Yeah, it's gonna be close to the moon. Want to give it a try anyway? Yes, yes. All right, let's go to M5. Let's disable stacking. Oh no, first of all, I'm just going to take a snap of this. It's really nice. Exposure time. Gain at 27. Good. Now everybody say goodbye to M3. It's really nice. All right, mode, enter. The stacking. Without stacking, it still looks good too. Go to. All right, here we go. It's so number one. Oh, I think it's above here. Let me see. Yeah, I think it's near the top. As you can see, I'm getting close to the moon. Five. Oh, looks like I am into electrical lines of some kind. Then this play with the exposure. There we go. All right, Jeff. Of 17, exposure of just about 2 seconds. Let's do some. All right. Good night, Graham. Oh, and good night, Michael. Yep, good night. Yeah, 18 viewers. Well, it was up to 21 at one point. It's actually doing pretty good. So there's M5. Maybe let's play with the histogram a touch. Good night, Bob. Oh, yeah. Oh, you're not saying good night to me. Okay. You're saying good night to the other Michael. Hi, Omar. All right, Jack. Thanks a lot. I'm curious to see what it looks like on on YouTube. Hi, Jules.